Okay, from echelon form, I can actually determine how many solutions this system is going to have. Let's see why. Now, there's many ways to go about this, but I will like to look at this guy. Now, if this is not 0, so if this is not equal to 0, then what happens? Well, what can I do? I could divide the third row by 8 minus 2k squared. I would obtain a 1 right here. So hopefully you agree I can obtain a 1 right here. And then what does that mean? I can create zeros up above and get a unique solution. So let's say that as, if this is non-zero, then matrix reduces to our perhaps favorite situation, unique solution. Okay, so what have we learned? So for unique solution, 8 minus 2k squared is not equal to 0. So that means that 4 is not equal to k squared if I solve that. So k is not equal to plus or minus 2. That's for unique solution. Okay, notice that h does not come into it at all. Doesn't matter what h is. So we can say h is any real number. So in English we'd say h is any real number, k is not equal to plus or minus 2. But in math we would write that like this: h is any real number. So that's my solution, that's my answer for unique solution. Okay, so what does that leave us? That leaves us 2 remaining possibilities, right? This breaks down nicely. We're going about it systematically, covering all cases by looking now at k equals 2 as one possibility and k equals minus 2. That's another possibility. I apologize about my 2's. I can't seem to be consistent with them. Sometimes I do them like this, and sometimes I do them like this. I'm sorry. You can't teach an old dog new tricks. Okay, so if k is equal to 2, what happens to this last row here? This last row, let's grab it here if I can. Well, if k is equal to, well, plus or minus 2, what do you get? The last row becomes 0, 0, 0, and what's that last one? 3h plus 1 minus k. 3h plus 1 minus 1, like so. And if k equals negative 2, the last row is 0, 0, 0. I want to say 3h plus 3. Is that right? So it's minus 2. Yeah. Okay. So if k is equal to 2, I get this as my last row. And what does it tell me? Well, it tells me that I'm going to have inconsistent, I'm going to have no solution. If h is not equal to 1 on 3, right? Because that will make this guy non-zero. So I'll have one of these rows that give an inconsistent system. And if h is equal to 3, if h is equal to 1/3, then I'll have infinite solutions. Okay, let's put that aside for a moment and go look at the case k equals -2. And we get a similar situation here. We have no solution if h is not equal to -1, and infinite solutions if h does equal -1. Okay, let's try to summarize this. So let's say summary. Unique solution. Oh, come on. Unique. If you have k is not equal to ±2 and h is any real number. Then we have infinite solutions. Gotta be a bit careful when we collect this information now. Infinite solutions happened here and happened here. So that is k equals 2, h is a third. But also if k is equal to -2 and h equals -1. And finally we have no solution is k equals 2, h not equal to 1/3, or k is equal to -2, h not equal to -1. Okay, I'll give you a second to write that down. I'll say a few more things. So what do? We took our matrix, we reduced it to echelon form. I chose to focus on the unique solution case first, and I found that happened when k is not equal to ±2. So there are only 2 more cases to look at after this. Well, there's the case k equals 2 and k equals -2. Once I figure out those 2 cases, then I'll be done. So I looked at those cases separately, and in this systematic way, I got my final answer. Now, we can perhaps, let's say useful to keep in mind here in these types of questions. Okay, so we're reducing to echelon form. Now, if the last column of the augmented matrix has a pivot, okay, pivots are also known as leading entries. So if the last column of the augmented matrix has a pivot, then there's no solution. If it doesn't, and every variable has a pivot, then we have unique solution. And otherwise, infinite solutions. Okay, so this is a kind of a outline of a strategy here. I want to indent, actually. I want to indent something. Let's indent this a little bit, just to indicate that when I'm in this situation, okay, I'm still in the case where the last column of the augmented matrix does not have a pivot.